Tinkerspace.
I had to go to here.
That's fine. Just don't try to go beyond. Just stay over.
My speakers not.
Yeah, otherwise if they go somewhere else and all that we yes. I don't think you go to the screen, you drop the screen. You mostly stay in that.
You can't come in front of this point.
And you don't have time.
Yeah, is the screen recording stuff is also good.
What?
Like, are we doing screen recording for the slides?
Not your slides?
Yeah,
For the other slides, yeah.
For the slides we have. Yeah, that's okay.
Oh, I forgot to bring my laptop. I usually record the screens. Are you recording? No, it's fine, it's fine. Don't worry about it. Let's start. Oh, wait, sorry. Okay.
കുറച്ചോ സൗണ്ടിന് മാത്രം അതല്ല അതല്ല Take seat. കഴിഞ്ഞ പ്രാവശ്യത്തെ സീനായിരുന്നു ലൈക്ക് ഐ ബി എം ലിമിറ്റഡ് സീറ്റ്സിലായിരുന്നു
Hello everyone. Could you kindly please be seated? We are going to be starting the Kochi Meetup, the first one for the year. I have been going around to people and they saying, "Yo, it's been a year since we have met." Got it. Okay. Yeah. So this is the first annual Kochi Meetup, the first one for the year. And as we do with all of the meetups, we will start with this quick introduction of FOSS United and what we do. So FOSS United is an organization, it's a computer-run organization to promote and create free and open source software. There are a bunch of events, they run a platform called Monk School, there is a community initiatives like FOSS Clubs, grants and the FOSS Plus and so on. And they run a couple of events. So basically, we have the monthly FOSS Meetup. This is one of them. And then we have the City FOSS Conference. When is ours happening? Soon. Okay.
by me. Sometime
Sometime in May, I guess. So we'll be having our Kochi FOSS City Conference. Then we also have the Premier Beta FOSS Conference, which happened last year in October, I guess. Yeah, October. And then we also have a hackathon called that, which happened last year in March. These are the current active city chapters. So we are there in a lot of places. This is the Kochi one. And these are our industry partners. So you can visit us. And there's also the FOSS newsletter. If you are really interested in all of the happenings around the FOSS space in India, I would recommend subscribing to it at fossnet.org/newsletter. Yep, that's about it. Welcome to the January 24 FOSS Meetup Kochi, and thank you to Tinkerspace for hosting us. Yep. So we'll get on with the talks, and the first talk which we have is about understanding language models, the transform architecture, self-attention, word embedding, and more by Gautam Krishna. It's actually setting things up.
So today I'm going to give a talk on understanding language models, which is basically large language models and other NLP related AI models. So before we go into a talk, I'll just give an introduction about myself. I am Gautam Krishnan. I am a CS student with specialization in AI in Ahmedabad University. I am part of my college FOSS club called FOSS, where I spend most of my evenings in the lab. Then right now I'm working on a few AI projects, one of which is a medical AI project, and the another one I'm working on a RL project at UCSC, a lab in UCSC. So that's about me. Now let's get into the talk. So this is the state of many of the developers right now. You go to Twitter, you see all the hype about LLMs, some LLM wrapper startups having funding of 2 million and stuff like that, and then other research, and people are like, AI is going to replace developers, and you just don't know what these LLMs are, all these language models are. So many of them are in the condition of Ruby right now, and maybe after the talk you can become like Buzz Lightyear, where you do the talking and your friends have to listen to you. So that's it. Introduction. So coming to LLMs itself, what are LLMs? So they are AI models that are trained on a large corpus of text. They can do things like classification, summarization, or entity extraction and stuff like that from any conversational data. And many of the common language models we know are ChatGPT, BERT, Llama, and things like that. Okay, so by listening to this talk, what will you learn? So first is the internal workings of the LLMs and jargons like embedding, context length, the attention mechanism, and things like that. Knowing these terms will help you to keep follow up with the latest research happening, and also to use their APIs and their other services. Then, basically you'll have an easier time working with language models in the future if you know these things. So, before we go into language models, let me give a general idea on why AI models itself work. If I have to tell that an AI model is basically a function approximator. It approximates a function. A function can be anything like give an answer to this question, like ChatGPT, or like does this image contain a cat or a dog, or like convert this text into an audio. And AI models just maps the input to the output. And it is based on the theory called the universal approximation theorem, which states that AI model with just a one hidden layer can approximate a function to arbitrary degree of precision, provided there are enough nodes. But it's a bit theoretical thing, and you can't. But in practically, you need specialized models for everything. So AI models and LLMs are the ones that map a text input to a text output. So today we'll be focusing on the transformer architecture, which is the basic architecture that is used by all modern language models. So they have a lot of concepts in it that was brought together, and because of which we got a working architecture that can be used for a lot of language tasks, and it works. So this is the basic architecture. I'll be explaining the parts of it, and in the end we'll be seeing how it's all brought together. So the main parts of it are tokenization, embedding, multi-headed attention, and later we'll see how it's all connected together. So tokens. We have heard of all these names called token, context length tokens used by models and things like that. So the thing is, like computers, even AI models can only deal with numbers. So how we have encodings like UTF, Unicode, and to convert the character sets into numbers. So similarly, AI models use something called tokens. A token is like a word, can be anything from a character or a word that is mapped to a number. We have multiple types of tokenizers. One is the simplest one here is the word level tokenizer that tokenizes every word, and every token has a number associated with it. So the popular tokenizers include word level, sentence piece, and ones like ChatGPT uses something called byte pair encoding. If I have to show you how these tokenizers work, we can go to the OpenAI site itself and show an example. So every colored word is a token. As you can see, sometimes some of the words, the entire word is a token, and in some other cases, a word is split into multiple tokens. So the thing is,
So can you pick increase the size? Control plus.
this is good.
Slightly more. Yeah. Can you scroll down? Yeah. This looks good. Yeah.
So the thing is, there are many, like I told, there are many types of tokenizers. We can either tokenize entire words or just characters in them. If we tokenize just the characters, the English language will have just 26 tokens, or 82 because capital and small letter. But the thing is, why we need to go to the length of tokenizing some words completely and some in parts is because the vocabulary size of a model is determined by the number of tokens that it can deal with. So if we have just character level tokenizer, we just have 26 tokens. But the problem with that is a character doesn't capture the meaning of a word or anything like it. It doesn't have a context. So if I am just giving a character T, it doesn't mean anything much. But if I am giving a token for today, it has a meaning, it has a context. So the model will be able to better capture the meaning of sentences if we have an entire word. But then again, if we are doing that, we need to have tokens for every word, and the latest models are like multi-language. So we need to have a word token for every word in all the languages that it supports. That really is not possible. The model will be very huge and training cost will also be very huge. So we have things like byte-pair encoding where we find the commonly used words will be have a token of their own, but the bigger, lesser used words will have like a sequence of tokens, the part that we combine to form them. So that's about tokens. Now embeddings, like you might have heard this term already. So embedding is basically nothing but storing the information, like any information, in a vector form. So it's such that the things, the objects of similar meaning have vectors that are closer to each other. So you can create embeddings of text, you can create embeddings of images, audio, anything. So what these AI models works with these embeddings. They take the input, converts it into tokens, and then these tokens are mapped into vectors that are embeddings. So every embedding, like for example, the embedding size for GPT-2 is 768, where every token will have a vector that is 768 columns associated with it. And the thing is, these embeddings capture the meaning of the word, and then you can also do algebraic operations on them. The one of my favorite example to give for this is that, let's say you have an embedding for the word king, and then if you subtract the embedding of the word man from king, and then to the result, if you add the embedding of the word woman, you will get a result. And now if you take what is the closest point to that result, then you will get the embedding of the word queen. Because like king minus man, you are left with royalty, and then you add woman to it. What do you get? A queen. So that's it. You can do addition and algebraic operations on these embeddings. And you get different models have different embedding sizes and things like that. So not just for the models itself, like now there are vector databases where if you want to feed like external context or information to the models, and you have things like RAG. So for that you can embed entire documents and store them in a vector database. In that also we use these embeddings. So like I said, I can show some visualization for it. This is the embedding of the GPT-2 model. That it is actually 768 in dimension, but it is projected into a three-dimensional space for visualization. These are all the data points, embeddings for all the tokens. Now if you search for a word like happy, you can find that. You can find that like the embeddings that are the closest to the word that we gave are the ones that have a similar meaning to it. Don't bother the question mark, it's a labeling problem. It's not there. So, and even now the points are far apart because like it was projected into a longer dimension usually, but if you take it to the original dimension, they'll be closer together. And this is how the models understand the meaning of every single tokens using the embeddings. self-attention mechanism. This is the main idea about the self-attention mechanism is what revolutionized the entire NLP and started the rush for LLMs and stuff like that. It is introduced in a paper called Attention is All You Need that is released in 2018 by Google's DeepMind. So basically what it does is before the AI models, when they got a sentence, they would just give equal weightage to all words in the sentence or tokens. But what the self-attention does is like if we are reading a long paragraph, we humans itself will be paying attention to the few keywords in the paragraph to understand what it is and what it means. Similarly, this self-attention mechanism gives that capability to the AI models. So it's a bit complicated, but this self-attention mechanism will allow the AI model to pay attention to the important parts of the input and generate the output accordingly. So if we have to go into the maths behind it, this is the math. Basically, you have one input, this is the equation. You have one input which is split into 3 and the attention score is calculated, and then you get a weighted sum of all the inputs which you again multiply into the input again, and then you get an attention, weighted attention. So this is done multiple times throughout the layers, and finally you get an output. So let's connect everything together now. So this is the architecture for the original transformer model. This is usually used for translation tasks. Let's say you have a text in English and you want to translate it to Malayalam. You use architecture similar to this. It has two parts. One is an encoder and the other is a decoder. So the encoder will take in the input text, encode everything, and then pass it on to the decoder, and the decoder will do the actual translation for you. So if we are looking into this, the input is fed into the encoder, and then it is tokenized, then it is converted into input embeddings, then you have something called positional encoding. So the embeddings itself only capture the meaning of the words. These, they don't have an order, sequence attached to them. So to give the concept of a sequence, how these embeddings are placed in relation to each other, you do something called positional encoding. And after that you pass it on to the attention mechanism, feed forward layers and everything multiple times. And then you feed it into the decoder. So that's how the encoder-decoder architectures work. But the language models like Llama and GPT are just decoder, where it just you just have this part, and the entire thing is passed through that. Now let's see how these LLMs are trained. So training LLMs is a very expensive and hard thing to do, honestly. So you have multiple steps for it. First is the LLM needs to learn the grammar and syntax of the languages. For that, you just scrap all the data from Wikipedia, Reddit, internet, and sites like that, and just feed it into the LLM, and it just learns how the words are arranged with respect to each other, what the meaning of each words are. This data will be very dirty, and this LLMs at this point won't be very useful. But after this, then you have other steps. One is called fine-tuning. So what fine-tuning does is that you train it again on domain-specific data. Let's say you want an LLM that deals with medical diagnosis or something else. Then you feed it the diagnostics data, and then it again learns the information about that. So that's fine-tuning. And the ChatGPT model is fine-tuned on conversational data because that's what it does. It has a conversation with you. So then the third point is RLHF. Again, the model sometimes it can the output it gives might not be what we want it to give. So to align it with our expectations, there is something called RLHF, which is used for making the models. So what it means is that it's called reinforcement learning with human feedback. You have a model, you make it have two outputs, and a human will rate which one is better. And you have this whole data points, and you train a new model with it to recognize which output is better. Using that, you again train the base model to give it more desirable outputs. This is important if you want to make sure the model doesn't give any dangerous information, or it doesn't align with other human values. So for that, we use RLHF, and ChatGPT implements it. So let's see, now we learned about training and how the model is built. Now let's see how the inference is made. So the transformers and LLM models, what they do is they have an input sequence, and what they do is they predict the next token in the sequence. So if let's say if you feed it, I want a hot, and then next thing could be a hot dog or a coffee. So it could be anything. So these models are just predicting the next token. Then you let's say it's I want a hot coffee. Then you add coffee to the input sequence and then you feed it into the model again. Then it predicts the next token. Then you append it to the input and do it again and again until you reach the end of the sentence, or there is a special token called end of sequence. So until you reach that, you keep doing it. And there are multiple ways in which it is done. One is called greedy search. So these models, when it predicts the next token, it is not just predicting, okay, this is the next token. Instead, it has an entire vocabulary, right? So what it's predicting is the probability that this token in the vocabulary will be the next one. So that's how it does. So it's a probability distribution. So what greedy search does is that it takes the token with the highest probability and just adds it to the sequence. And then it keeps doing that. So this is the most simplest and easy to do one, but the problem with this is that it might not always generate the best result. Because the one that has the most probability now, or the token that has the less probability now, might generate a more coherent answer down the line. So we came up with things like beam search, where you take the first 5 or tokens with the highest probabilities, and then you append everyone one by one and do it again, and then you take its output and the first 5, and it goes on like that. So this is better than greedy search, but the only problem being it takes a lot of computationally very expensive, because you have to run the model multiple times to generate multiple outputs. Then the last one is called case sampling. So in this, instead of taking a Boolean beam search, you just take the top 5 of them, from let's say top 5 of the tokens with the highest probabilities, and do a probability-based sampling from that, and then do it. So many of the modern language models use a different version of case sampling technique. So yeah, this is how you do inference. So that's my talk. I hope you had a basic understanding and idea of how LLMs work. If you have any questions, you can ask, or if you didn't understand any problems.
Right. So LLMs are basically just at the very least is a statistical inference, I believe, right?
Yes, yes.
So how come they are finding the answers? Like for a particular question, if it's statistical based, you're just making patterns out of it, right? Of all the data. But how does it understand that it is an answer?
Like it doesn't have, like what it does is, in the training data, the data will be there to your specific question, and it knows that when there is such a sequence, the next token, this token is statistically the most probable one. So it just gives that token. Let's say you ask the question, what comes after 3? Then the answer is 4. So in the training data itself, there will be somewhere it must be like, it's in the numbers are in the order 1, 2, 3, 4, stuff like that. And then all of this context is captured by the model during the training. So it knows what, when a question like this is asked, the next most probable token is 4. So it gives the output as 4. But it will not always be right. These one thing AI models are currently very bad at is that accepting that I don't know the answer. Like ChatGPT sometimes does that, but then again that's just because it's fine-tuned to do that. So if it doesn't know the answer, it can come up with random answers. That is called hallucinating. It really gives the wrong information, wrong answer to the question that you know. So the AI models itself doesn't have a concept of question or answer or anything. It just sees this is the previous sequence. So statistically, this token is the one that follows it. So it just gives the output like that. It can be right or wrong.
Okay. In the case of programming, for example, it is generating code in it, but it doesn't mean that that code was written by someone else's anyway before it. So in the case of code generation, even learning the manner of how to generate code or to know a concept itself is converting a concept into code.
Yes.
But it doesn't mean that there was a previous statistical, like someone else in the world was already done it right. So it's kind of inferring a new thing from already existing.
Yeah, that is because it captures the meanings of, let's say, all these training data, and it can find patterns. It can, that's how AI models work. It searches for patterns and it understands the patterns, and according to the patterns it generates the output. Especially for programming, you have all these conditional loops and for statements and stuff like that. So if you say, okay, this is a program for generating Fibonacci, and that is there in the training data, then it will see the pattern. And then you have, if you ask a question, okay, generate me a program in another language for generating Fibonacci. So in this, like the pattern, the model will know it already. It's just that it can give it, apply it into a different data. So it looks like intelligence, but it's not intelligence. It's just, again, it's taking the pattern and applying it on a different kind of data. That's what AI models do. Thank you.
We'll keep this mic for Q&As.
Introduce it. Yeah.
So next up, we have our resident hacker extraordinaire, Mufid, who will be going through reverse engineering Windows to build an IME for Indian languages. So that will be fun. Okay, so handing it over.
Hey everyone. So today I'm taking a talk on reverse engineering Windows to build an IME for Indian languages. So IME stands for Input Method Editor. So that's what you use if you want to use any other language other than English. So if you want to input Chinese, for example, or Hindi or any other language to an operating system, you use a system called IMEs. So that's this talk is all about. So before we start, I'm going to introduce myself. So a bit of a brief introduction about myself. So my name is Mufi. I am from Kundangalam. Now that will come to honest in a minute. So I'm the founder of Liberal. It's a micro ISP. Basically companies reach out to us with hard software problems, or basically sometimes we get to legally hack them, which is super fun. And I have competitions, and that's what I'm kind of known for. So I participated in this competition called World Skills, which is basically the Olympics of skills. So if Olympics is for sports, World Skills is for vocational skills. So I participated in cybersecurity and got the national or India national gold medal, and then represented India at South Korea for the finals, and I'm 8th worldwide. And also for BRICS skills, which is Brazil, Russia, India, China, and South Africa, and I got the bronze medal for that. So like I enjoy participating in competitions and winning them, so that was that. So that's my about it. So what's this talk about? So there were no Windows input method editors for Indian languages, and but there was one. So it was called Google Input Tools, and it was very popular actually. A lot of people, like especially government employees here, usually used to share this software with like USB pen drives because like it was so good. And anybody can guess like what happened to that software?
Killed by Google.
That's right. It was killed by Google. Just typical fashion. That's just how it works. So so I decided to build one, but it wasn't my idea. Now, if you saw the posters to this event, you would know who this dog refers to. It's this dude. His name is Subin. He's also from the same place as me, Kundangalam. Yeah. And this represents me after all the trauma. So it was just during a random conversation. Yes. So it was just random conversation. I was like, you know, like I had thought about doing something in the modern computing space. Like, do you have any challenge in mind that could make a good contribution? And I especially added like the more challenging the better, because you know it has to be stimulating. I got to work on it, right? So I went to something. And this guy says, do you want the most challenging thing ever? It would be making an input method in Windows in Rust. Rust, because nobody wants to deal with Microsoft's Visual Line BS. If it's made, it would help a ton of people in Kerala and the world. World, because open source IFP said that's necessary to set up in Windows is very less. Now I was convinced by this, like that's good. Now he also said this, but I would be a godsend if we can work on this. I started a bit and just gave up. Now just gave up kind of caught my attention, to be honest. I mean, it got me like this. But I thought, it can't be that hard, right? I mean, what's going on? So I said, there are Windows clip bindings because there's a Windows clip for Rust. So I thought, I can just use that one. That was that. And he said this one last time. Let me rephrase this. This will be revolutionary if it can be done. Now after that, I was so like, okay, I'm going to do this. Like, there's no way I'll just. So like, I went all in basically. Now, you might ask, you know, the executable still exists. You can get it from Uncover or it's Google Input Tools. You can just use that. You know, there's like a beer drug dealing. That's how government employees can share Google Input Tools. Now let me show you one thing. It's kind of funny, to be honest. So Subin sent me the executable for Google Input Tools, I think 2 days ago, and then I reverse engineered it because I want to know how it works. And I'll show you the first thing I saw. So this is IDA, it's an interactive business controller. This is a tool for reverse engineering. So I opened that executable, and the first thing you can see, informs home. It executes a shell command. I don't know if you can do this, but so zooming in IDA it's kind of hard. So it's basically forwards home. It executes a shell command. It sends a request to a URL that doesn't exist anymore. That was also built by Google 404. So that's, you know, you cannot use that basically. So before I tell you about my journey of making a method editor, I'm gonna give you a brief history of the one project. Now, so we must find out. I asked him like, can you give me a brief history? And he literally wrote like an essay, like ChatGPT style. He just wrote everything. So this is I just organized it. So it was started in 2010. It was started by Navneet KN, and there were a lot of apps built on top of that. It was called Live One.
Another thing, nowadays also the sugar.
Hell yeah, dude. Okay. Then I want to make it a stable input method in 2014. It was part of GSOC. In 2017, and these are the applications that are built on top of Go. This is the GitHub URL of the one project, and this is the website, you can check it out. So this project is under Varnam, so it is a Varnam input method editor for Windows. So yeah, that's the introduction to that. Now, when he told this to me, I mean, you know, my Kumbhakolam senses were tingling. I just knew, like, someone would have already done this. I don't have to reinvent the wheel. Like, come on, you can just look, someone else would probably done it. So I searched for it, and also I found this funny YouTube video, and the thumbnail says duplicate. So like, just kind of like for the uninitiated, I just wanted to introduce like what Kumbhakolam is known for, and also jokes on him. I can actually get my mom and dad from Kumbhakolam because they are from Kumbhakolam. Okay, anyway, yeah. So I was right. So someone in China actually made this project. It's called IME-RS. So he ported the Microsoft IME, the sample IME CPP code to Rust. So it's a one-to-one port. It actually still uses some CPP code, but it's an incremental rewrite. So I was right. So you know, I found it basically. So I copied that project, but I don't know if it's like viable enough that I can use it, right? So I was kind of scoping the project, like reading the issues and stuff like that. And one issue caught my eye. It said, debug build failed to compile. And I was like, okay, if it doesn't compile, then how can I use it, right? Then I took a closer look, and that name is familiar, you know. Alan Paul Varghese, that's this guy right there. So I knew there were people before me, and I didn't see no one on my IME, so I knew what's going on. So I knew this was a problem being tackled by a lot of people.
Did you fix that?
Yeah, it's fixed. So how do we create a native IME for Windows? Now, I'm not going to get into the intricate details of it because in 30 minutes I can't really cover the technical details of that. But I have kind of like devised like a fun, digestible way of like how it's structured. So I copied the screenshot of the docs from Windows. So how to create an IME? So an IME is a DLL service. So it's simple as that. It's a DLL service that you can register as a server, and it would just run in the background, and that's that. It's a COM service to be exact. And there are some requirements for custom Windows IME. Now when you look at the docs, it has to be digitally signed, and it has to be a test service framework because there was an IMME 32 framework. That's old, so you cannot use that anymore. So you have to use test service framework, and you have to follow the guidelines for the IME. And legacy custom IMEs will be blocked. And IME must be compatible with Windows apps, so that's the one, IMM32. You cannot use that. If you use that, it would just, Windows Defender would say that's malware. And it should be compatible with system tray. And it's just a lot of requirements. Like, IME must work in app container because it runs in a container for like security purposes. Because it handles like when you access a file and stuff like that, and internet and all that stuff, it runs inside a container. So you have to adhere to that. I think it's like if you try to supplement the app container security rules, well, I may be treated as malware and blocked. Like these many requirements, I don't know, like not even BSNL customer office at lunchtime has this many requirements. Like, and first of all, I actually read this afterwards, so it doesn't really matter to be honest. So yeah, how is this project structured? So I copied the project from my side, and it uses multiple languages. Now, the original project uses C++ and Rust. So C++ is the original code. It's a sample IME for Windows that was written by Microsoft, and it calls Rust. Now, I'm using Go, written by this dude. So I have to use 3 languages. So in this project, C++ calls Rust, and Rust calls Go. Now, how that looks like inside a business umbrella is kind of like, it stings your eyes to be honest, but it works. So that's how the project is structured. Now, you might ask, like, why can't you just write it in C++? Now, after all, sample IME is written in C++. It was by Microsoft. It's official. It's the latest code. You can use that. And you can also do FF5 code function interface in C++ to call the Go on code. Now, that would work. You can also statically link them because you can just ship the Go runtime with it. It would work. It's totally fine. So, like, why would I use a Rust code with it? Because the works completely fine. Now, I have my reasons for that. I'm going to present that to you. Number one, I want my hair intact until I'm 30 years old. No one can write C++ these days. Rust will drive more contributions. Basically, people get a lot of contributions because like no one's gonna like C++ like that. That's just how it is. And memory safety, selling point, and number four, I want my hair intact until I'm 20 years old. So now that is out of the way, I'm going to show you the initial MVP that I did. So what happened was that my friend Vivek, I don't use Windows. I haven't used Windows in like 4 years, I think. So my friend has a spare laptop, and he told me like he's not using it. You can do whatever you want with it. So I thought, okay, maybe I can flash Windows on it. And then I remember, oh, Subin gave me a challenge. I had to write this IME. So this was the first version I did. I kind of like hacked on a bit. And this doesn't actually call Governor. It's just an API call. So one is a web API. I just called that, and then I just wanted to see how it looked like and it would work, and it did. So that's the initial MVP. Yeah, so now getting to the technical details. So yeah, how do you compile C++ in Rust and statically link them? So there's a tool in Rust called cbindgen. So that's how you can generate bindings basically for Rust to import from C++. So you can just use that tool to just generate the bindings. You really don't have to write any code for that. It would just do it for you. So this is from the build script. It's simple as that. It just generates the bindings for you. Now, how do you call that function? So this is where it starts. So you call this function from C++. Now this is calling the function from Rust. So I'm going to show you the first step of how it works. So in CPP function, you call the get candidate list. So in this particular context, get candidate list means like if I said kill, it would say killadi. That's the candidate for that. So it's basically like suggestions or an autocomplete basically. So this function would give you that. So this is the main C++ code, and this is the header file. So this defines the function that we're calling from. So this is the Rust code's definition in the header file.
I'm so happy I'm not the one writing those.
I wasn't happy either, man. Yeah. So this is the Rust code, the F5 code. So extend C, which means like external C code, and that's how you define that. You have to do what's leak for all this stuff. I mean, memory safety, I guess. And it calls the engine function. So tuples F5 is basically like you have to have a return type that's supported by C, and in often cases it's just numbers, to be honest. And this is the main Rust function. So this is the function being called. So it's simple as that. It calls one concentrate. It will send the keystroke buffers, like what I'm typing, and it will just match with that and then send you back the candidate list. Yeah, so now that's out of the way. So that's how you call Rust from C++. Now how do you register this as an IME? So like an IME service, you have to register that for the operating system to know, like, okay, this is the input method being used. It's basically, it's pretty simple because Windows mostly works with registry keys. So if you're familiar with that, basically you can do like get it. Probably most of you would have used it. So you would just create a new key for that. What this function particularly does is that it instructs Windows on like what sort of service it is. So it gives the labels for it. So these are, I mean, it says apartment and stuff like that. It's not the same apartment. I mean, Windows uses that lingo for like a particular service. Yeah, so behind the scenes, this is what it does. This is from the Microsoft Docs. This is the functions being used. So dear register server, dear unregistered server, these are the functions being used. And it's pretty simple to invoke. To execute that, you just use the command like str32 and then the DLL. You get errors like this all the time. I have only seen the success message a very few times, so I just wanted to kind of like give you the experience of like what I saw most of the time. You know what points me in my nightmares, I guess. So like, yeah. And yeah, so you cannot just register an IME service. You have to have profiles for it. So profiles say like, okay, this is an input method editor, and then it supports this and that. And most one of the arguments. So it tells Windows like, okay, for Hindi, this is the input metadata. So I can just configure that. So there are 14 languages that one supports, so I can just take them, like, check what's it basically. So I can just, the same dealer would be handling multiple of these languages. So it's like pretty elegant if it works that way. Yeah, so then you got to register the categories. I know I probably should have put like a Subway Surfers gameplay or something on the side, because like, I mean, it's just, this is how Windows works. You know how easy it is to like do an IMU on Linux and stuff like that? Or like things I have to do because I accepted a challenge, but I didn't. So yeah, so you gotta register all these categories. It runs in secure mode and stuff like that, and that's how Windows knows. Okay, so this particular service runs in these specific set of categories. Yeah, so I just told you how to register the profile and stuff like that. Now I'm going to tell you like, okay, so how does Windows know what Malayalam is? You cannot just send a string. Like you cannot just say Malayalam, then Windows will understand that, because Windows has a table for it. Windows recognizes some of the languages, and Malayalam is in there, and most languages are in there already, and it has a specification for that. So it has a specific value for each language is assigned. And there's a specific, pretty much there's a specification in the documentation that says like, okay, this language has this ID, this language has this ID, and stuff like that. So this is what the dog says, again, CID structure, Windows language programmable, a lot of stuff, and I honestly did not read any of them, but I'm just going to show you. And it also has this page, security considerations, and it just says none. Yeah. So I did not read this documentation. I just I found them in the Rust crate, so that was way easier to be honest. I was just clicking things. You know how nested that is? So I just clicked and found this, and it says language Malayalam has 76U32, so that's the ID for Malayalam. And then there's sub-lang for like multiple dialects and stuff like that. And Malayalam only has one, so it just says one. So that was easier. I didn't really have to read all that security considerations, none, to get that. So how does this look in code? So I just stored it in a hash map. You know, if you have done a lot of leak code, you know, you can just use hash map, and it just works every single time. And this is how you register language for Malayalam, and this is for like each unique identity. So like this is a bitwise operation, and it would just register as like for Malayalam it would be 1100, and then so on and so forth for like each language. And that's how we can register them. So when you call them, like okay, say I want Malayalam is the key, or like this is the key, and you just say, okay, this is the language being used. So we just work that way. Yeah, so I told you already that the DLL IoT service works inside a container, so that's for security. You cannot just read files with it. So like if I made an IME that included a virus, I would be able to read your files. Now, the container wouldn't allow you to do that. Now that's a security consideration, and it should be there. So whenever you want to read a file, you have to do this. So you have to get the DLL instant handler, so it will give you the path for it. It's a secure path, kind of like a virtualized path. Then you get the modular file name, and then you join that path, and then you use that. So like, and also every single record you have to do this, go initialize X, otherwise it wouldn't work. I don't know why, but that's how it is. So like, I believe it's for like the form service we register on every thread. So that's the only way you can make a file.
What
Yeah,
kind
so
of constructor is that? What kind of constructor is that?
sure.
The co-initialize X. Is that a function?
Yeah, that's a Windows function.
Okay.
Yeah. So the way how one works, one has a set of schemes. So schemes are basically BSC files. Now BSC files are basically SQLite databases that has a set of words for each language basically. So you have to load them, and that's the reason why I showed you how to read a file inside from the container basically. So you have to use that every single time. So you get the current active language ID, and then you match with them. So if I'm currently in the Malayalam mode, and it should read from the Malayalam BSD. Now, OneNote specifically identifies languages from the DSP file, so like it depends on what file I use. So it's pretty much like an SQL database has this set of words in it. So it's like pretty easy. Like if you want to add a new language, you can do that because it's just an SQL database. You can add words and characters that are supported for that. So it's like it's pretty convenient to be in that way. So like in this specific example, it's using all the languages that are currently supported by OneNote. So for each language, it will load the SQL database. Now the learnings file is when you type a new word that you want to add to the database, it would be in that specific learnings SQL database. So it would, for like custom words, like manual words, you can just add it to that. And it would just initialize OneNote with that SQL databases. So like when you type, it would match the language that you're typing, you understand what language you selected, and it would just match that. Yeah, so now that's out of the way. We have to call OneNote for Plus. Now fortunately, Alan actually already did that. So Alan made Rust bindings for OneNote. So I practically just use that. This is the library that is used to call OneNote from Rust. So that was really easy for me, to be honest. So thank you to Alan. Yeah, so now one problem, however, that a lot of people face in the Telegram group is that it was not just me. A lot of people were attempting this specific problem, and a lot of people found it hard to generate a DLL for Go. And it's a bit weird. So I'm just going to show you the file how that's built. So the entire build process for this project in a zoom in. Okay. Good. So the entire build process for this project is in a single PowerShell file. It's not in a make file, but this works. Okay. And ChatGPT found it easier to write this one than a make file, so I used a PowerShell file. So yes.
Makefile works on Windows. Makefile, it has a separate dependency for it.
Yeah.
The GCC make only.
Windows has native support for PowerShell, so I thought,
Yeah.
not that ChatGPT can write it, but so okay, yeah. So so I call this function, call this batch file, call Windows build, and that's the basket that compiles for Windows as a DLL. So first, I install the latest schemes. So schemes, as I said, was the language databases. So that's updated in the beginning, and then we will use this flag for the exports. So and then set the lib name, that would be the DLL file, and then you give all these flags. I mean, I don't know why Go made this like this hard to generate one, but like I had to play with this a lot to kind of end up with this solution. And this whole script is responsible for generating the DLL for Go. And that's called from this PowerShell script. Yeah, so that's how the DLL for OneNote is generated.
Visual Studio run
Nope. But it actually uses the Go and compiler itself, like it doesn't run.
Visual Studio
Nope. Just uses plain old command line, to be honest. Yeah. So how does the Go on Rust picks up the DLL? So like in Windows, you need to have the symbols for the DLL. So you define that in files like lib and pub. It's PDB, right? That's PDB type. So it has. So you need to have this in a registered path. So like in an environment variable, you have to register that path, and then it will only detect like, okay, this DLL is installed in Windows 1. So this is the build.rs file in the Go on Rust. So it basically reads the dynamic library, Go on, and then it builds the binder with that. Yeah, okay. Now here's a funny story, right? generated all that, wrote the first version of the IME, and then I kind of shipped it to my friends. So like 2 or 3 of my friends, and I asked them like, okay, does it work? And they all said it works, and they said that they all sent me a screenshot. And I was like, okay, this works not just on my computer, right? And then I sent it on the one on the Telegram group, and then it wasn't working for people anymore. So I was like, okay, that can't be the case. And then that's when I figured out that I live in a bubble, because it used Visual Studio dependencies, and all of my friends that I sent that DLL to were developers. So they had Visual Studio installed in their computer. Now, the target user of this whole thing wouldn't have Visual Studio installed, so it wouldn't work. So I did what you know, the most sensible thing to do. Some might call it Jugaad, but it works. I just copy pasted the System32 DLLs in my machine. That's the Visual Studio DLLs, and I just shipped it with the executable. It works. I mean, no one's gonna like, you know, check it out and then see, oh, this guy shipped all this DLLs. And some people ship DLLs, but like that's how it works. I mean, I can't just. Some software actually asks people to like download Visual Studio, and like, dude, I don't think that guy in Secretariat is like, oh, Visual Studio, I'm going to install Visual Studio, and then type Malayalam, like, what? So I had to ship them, and that works.
Windows പൊതുവെ സോഫ്റ്റ്വെയർ ഷിപ്പ് ചെയ്തിരിക്കുന്നതന്നെയാണ്. വിഷ്വൽ സ്റ്റുഡിയോ ഡിപെൻഡൻസി ആണെങ്കിൽ പണ്ട്
No, you have to install the indisputable.
Yep. So there's 2 ways. So you can either statically link them, you can just combine them as one, but that has some problems, like mangling problems. So people usually just ship the DLLs, to be honest. Now the funny thing here is that this uses the debug version, and that's the reason why there's a D suffix on this DL first, because the Visual Studio dependencies are debug versions. And IME registration only works in debug versions. For some reason, it wouldn't compile in release mode. So I have to ship these instead. And most Windows software actually ships it like that. So like, I meant Jugaad in the way like literally every Windows developer do Jugaad, you know. So like,
Does it cause any license issues?
no,
It is not a Jugaad if it's the standard we are doing.
pretty much. So we can put Jugaad blade on Windows then. Okay, that's fine. This is being recorded. Okay, that's fine.
I will do next.
Wait, I don't know if I went too fast. Okay, well, so we have to hope all of that works in harmony. So like, you might have seen videos of this. It's called the Blue Goldberg machine, and that's how this project works. It's pretty much like a metaphor of how this whole thing works. And now I will show you the demo for the one on Windows. Now I am on a Mac, and this is on a Windows, so I screen recorded it. So I'm just going to show you the screen recording. That's the demo. Okay. Yeah. So you can select the language, select Malayalam, and then you can just type it like that. See how seamless it is? It's just so good. Hindi. I don't know the Hindi, I'm sorry, man. Then you can do another language, you know, number 2. Right? Yeah. So yeah, that's how the IMU works. Pretty smooth. You can change languages like that. Yeah. So I also want to show you one thing. Because specifically titled reverse engineering. So I'm going to show you some kind of like an overview of how this looks inside this assembler, because you have to see this. This is what I saw in my nightmares. So this is IDA again. This is how the one on Windows DLL looks like. So the blocks above are each specific language, and the jump condition goes for like, okay, this specific language can be used. Now, definitely we're not going to read assembly, so I'm going to show you the decompiled version. So yeah, as you can see, it's different schemes. So you can kind of compare. The reason why you use such a software is that when you write DLLs and executables like that, you don't really know like how it would be represented, or like how the symbols are generated, especially since you use like multiple languages in this one. So like you can kind of see like, okay, this is how the optimizer made the code. So Rust specifically uses LLVM, and it also has any in-house optimizers, stuff like that. So when you write code, it wouldn't really represent the way you want it. Sometimes the symbols would be kind of in the scenes. You have to like analyze how the executable looks like. So this is the and again you're not going to read assembly. And and this is how the government DLL looks like. So I did a basic string search, and you can see these are the government functions. So you can see, okay, so these functions are successfully generated, these symbols exist in that DLL. Because if you use that DLL, register that, and then you just try to make it work again and again, but the symbols were not there the whole time, you would be wasting your time. And I think the people who worked on this project actually asked me, like, how did you ensure that it worked every single time? Because it would just crash if the symbols were not there. I think Ellen and the other people shared with me, like, when they create the project, sometimes it just randomly crashes. Now there are two reasons for that. One would be the symbols are not imported correctly, or Go has a runtime. So like if you use it like kind of like infrequently, it would re-update the garbage collector, because that's how Go works. So it has to free the memory. It's a garbage collector language, so it has to do that. I will actually show you how I solved that, by the way. So the first thing I did was that I registered the government DLL as like a lazy static. So it's basically like a cached version of it, so you only run it once. But the problem with that is that once the memory is freed in the Go runtime part, it would just go away. So that pointer would no longer exist. So when I call the Go transitory function, it would just not be there. So you might be asking, did you bin it? Did you just allow the memory leak? Did you remove the garbage collector from Go? I'll show you what I did. So I just called government on every single keystroke. It was fast. I analyzed it. It just took like a couple milliseconds. But I tried building it, and it also has the same problem. And I'm like, I'm not going to take out the garbage collector. And I think the SQLite version used in government has some sort of like a C binding or something. It was a nightmare. So what I did was that it just calls government on every single keystroke. So I optimized, right? And the thing is, SQLite is fast. It just takes a couple milliseconds. And you saw the demo, right? A little bit of lag, but I will fix it. Okay. But this works.
But does it run on a government potato laptop?
I actually sent the SQL to my mom. So for that, my mom works in secretariat. So it didn't actually install, by the way, but I have sent a fixed version of it. It's like a real bad person. Like if it works, they will really share it, to be honest. And actually, one thing, recently they were actually having talks about, because literally everyone uses Ubuntu now in government offices. The reason is simply this, because my code is way easier than Ubuntu. You can just set that up easily, especially with fonts and stuff. The default fonts for Windows are like kind of hard to set up. So they use Ubuntu, and
Now they're going to go back.
Huh?
Now they're going to go back to Windows.
Wait, that's actually bad. Wait, I am at the FOSS conference and no, wait, Windows, no. Okay. This has to be done. Some people prefer Windows. My mom actually prefer Windows. I'll convert her. No problem. But like, yeah, so if this works, it's a good product. A lot of people need it, right? Not everyone knows how to use Ubuntu. Not everyone's gonna open Chrome with like a terminal, like compiling from scratch. Only us leader ways do that. So I just import them every keystroke. Stuff down. And now you gotta ship it, right? Now the thing is, I showed you how to register a DLL. So use rect SQL32, that command line. Now, circling on the same topic, like the main target audience of this software are non-technical people. Like they're not gonna open a terminal and say, like SVR, like the Matrix PTM would play in the background, like are they hacking? No. So they have to have a setup with them. So you gotta set this up. So this lets you select the language. You will select like which language you want. And it's kind of funny, like see this user interface, like it's so peaceful and stuff like that. You don't know it works in the background. It's actually like 3 executables running at once. So the compile languages, yeah, this one. So when you select each language, I just run like a Rust script in the background, which sets a JSON file with like what languages you enable. Now this is standard, by the way. It's like JSON configuration and stuff like that. But like the executable has multiple DLS and executables, which I will discuss later on. So yeah, that's how it works. Yeah, so I use Windows setup. It's an open source setup wizard creator. Oh, okay, I have to show you. Okay, yeah, so I'll show you how the install script works. Now you might have seen that I use 3 languages in this one: C++, Rust, and Go. Now get this. We have Pascal. Yeah, we have 4 languages now. So I'm gonna. So you can see this like a beautiful abomination of a setup. These are Pascal code. This is the behind the scenes of how the setup wizard works.
At least it's not base 64.
What?
At least it's not some random language. It's Pascal.
It's Pascal, but we have 4 languages now. But this is actually a really good project, by the way. InnoSetup is really good. All the other solutions are kind of commercial and then are open source. InnoSetup is the one that's like kind of top of the line. It's also open source. They use Pascal, but like I found it kind of hard to write Pascal for the first time, but that was funny. So yeah, I create C license and stuff like that. This is the language enabling function. It also adds the path. So like when you register the DLL, like, the path that the DLL resides in, the Windows has to know like where that is. You can see that this is the part where it executes the exe for the language compilation. Yeah, so that's how the thing works. And there's also another executable is for VLF import. So that's for importing the learnings file, SQL database when you set up. So it has to be run on setup. That's how it works on every single OS, and that has to be done. So I had to run that in the background as well when the setup is being run. So it's a kind of like a 2-step process. It registers the DLL, and then it imports the learning file. So like learning file are basically the words that you have as custom. Yeah, so there's also uninstall. You would just unregister the DLL. So that's how the setup works. The project just wasn't fast. Like, there was nothing, to be honest. I mean, they're finally like top of the line. Like, that's the only solution, to be honest, like at the moment. It's like my last talk, I talked about exit code, right? That's in Perl, but like even Facebook and GitLab use it. And no one else has a better one, because like that's the top of the line. And this is the same thing, like, setup is the best one that currently exists. With this sort of qualifications, like, you see that I'm doing like the war crimes, right? Like I'm executing like multiple executables and stuff like that in the background. Like if you want to do that in a setup, like that's pretty hard. Like, so they allow you to do that. You can just write passive code in the setup. So you have to understand, like, it also runs kind of like a runtime thing. So it's like really cool.
Is this actually maintained?
Yep.
Still.
I think one guy maintains it. Yeah.
Installer exe file ആണ്. Installer exe file ആണ്. അത് ഉണ്ടാക്കിയിരിക്കുന്നത് Pascal ആണ്. InnoSetup ഉണ്ടാക്കി.
Yeah, so InnoSetup actually has an editor too. Like you can like write code and compile it, build it, and you can also compress files into it. Like it's actually really cool. So you can pretty much like write any kind of setup wizard with that, because like, yeah, it allows you to write code. Because usually it's just a click, drag and drop, stuff like that. Like that's like not that configurable. Like for major parts, like that's fine. But for this one, we have to do like quarter clients. Like Pascal is the only thing. Yeah. Yep. Now, okay. So when you install this executable, Wirestarter would say that it's some malware. Now, I know I work in security and stuff like that, but I can be trusted. This project is open source, and it does not contain any virus. I'm not shipping any executable. And also, Windows Defender will also scream at you like 3 pop-ups in 1 second, because I'm running 3 executables in the background. So, just like, ignore it. It's safe. You can trust me. Like, literally me. Yeah. t-shirts for typo fixes, but it's indie hacking, bootstrapped, Rust, blazingly fast, open source, and multi-language, fast, C++, Rust, Golang, Bash, Batscript. What else do you want?
Varnam as Ruby as well.
Hell yeah, dude! All of them. Like imagine your resume, you contribute once to Varnam, expert, 6 languages.
Make Web3 project somehow. Web3
Blockchain. Varnam learnings in blockchain coming soon. Yeah.
Anyways, you are getting security.
Ethereum layer 2 go Varnam bindings.
Storms.
Varnam coin. Sukir is dying.
Why do we get the
So yeah, so I'm actually pretty serious about this. This is not a joke. I'm actually looking for contributors. Like, I don't care if you're a beginner. I don't care if you're an expert. You can DM me on Telegram and I will help you with it. Like whatever you want, I will help you with it. This is my username. It's Myofi VH. It's like it's my name with like a cat sign. I like cats, so like that's what it is. Like, you can just DM me. Yeah. So this is not the end of the story. Now this guy right here actually set me up with something else. And in one Telegram group, this guy was like, Mufid was saying to me that he needs some difficult challenges. Well, here's another one. And he was like, he gave me the Windows default font problem, and I remember a lot of people told me that. Like, it's like super hard to do that because the background service would clear out whatever language whatever default font you write into it. So I knew it was a hard one. But the thing is, like, when someone says a problem is hard and no one has solved it, I was like, okay, I want to do it. Like, it's just how it is. So I accepted. But after the previous one, I looked like that, but still we go in. So I solved that. So I solved that too, and that will be releasing soon as a GUI app, so you can set whatever font you want as the default for any language of your choice. So this is kind of like, so I set Meetup as my own font and stuff like that. And
like the problem Windows India type ചെയ്യാൻ പറ്റില്ല. India കണ്ടു കഴിഞ്ഞാൽ ഞാൻ India കഴിഞ്ഞിട്ടുള്ള വേ വരിക. അത് കുറെ വർഷങ്ങളായിട്ട് വിൻഡോസിലെ പ്രോബ്ലമാണ്. ഉത്തരവാദി മൈക്രോസോഫ്റ്റ് ആണ്. പക്ഷെ അവരെ ഫിക്സ് ചെയ്യുന്നില്ല. കഴിഞ്ഞ 15 വർഷമായിട്ട്. അതിന് അവർ ഫിക്സ് ചെയ്യാനും പോകുന്നില്ല. ഫോണ്ട് മാറ്റി കഴിഞ്ഞാൽ പ്രോബ്ലം അവസാനിക്കും. എല്ലാവരും പൊതുവെ പറഞ്ഞ പ്രശ്നമാണ് എന്താണ് എൻ്റെ വർക്ക് ചെയ്യാത്തത്. അതിന് സൊല്യൂഷൻ.
So this is how we make it work. And I'll tell you how I did it. It's the same exact style of the previous project. Some might call it Jugaad. Okay, this one is actually Jugaad. Okay, so the way I did it is that Apple introduced some meta tags called DLNG and SLNG. So DLNG is the designed language, and SLNG is kind of like what language it supports. Now, this is a meta tag introduced by Apple, but this is kind of like de facto used for like referencing. Okay, this is the category of this particular font. So you know what I did? So you get the font that the user wants to be as a default for language, and you add the designed language as the select language. And then you just overwrite the other ones with like random. So it's baking it, so like Windows would think like, oh, I have only media for as a Malayalam one. So you would just set it as the default. So that's how it works. You just fake it. And that's it. Okay, what funny thing is, in the previous project, I copied things because I'm from Movement. And recently I moved to Dubai because I moved my company to Dubai. And I just started faking things. So I just stayed true to my place. And also, maybe you should now wish for me to move to Pathanamthitta.
What is Pathanamthitta? It doesn't exist. Does it exist?
At that point, I'll just delete my GitHub profile. Doesn't exist. So yeah, okay, yeah. So if you have come to my last talk, you know my signature last slide. Ask me anything, like Ama. Yeah, and this is my username on
Hey, Rupert,
What's up?
how long did it take you to build it? Like, from the first conversation, so that how long did it take?
So the first MVP just took me like a few hours because I only caught the API. But the serious version, 2 days maybe I think. But it has overall like a lot of updates. So like the first version was like a kind of like a scratch. Like I'm just executing random functions at that point. So I'm just there's no structure for the code. The code is like super bad. So yeah, because I want to know if it works or not, right? Then I will clean it later. So like I guess it took me 2 days to build the main thing, and then the cleaning up would be like another day or something like that. But like, it actually did take a long time to kind of like structure the whole project because especially the setup and all that, because like it's Pascal. Like I never touched Pascal before, so I kind of like touched a lot of languages.